Hello and welcome back. We will be doing a hands-on deep dive of EDA or exploratory data analysis. We will be utilizing the book Statistics for Data Scientists. This is excellent for beginners or those who are veterans in the field. We will be covering data frames, structured data, and estimates of location. Let's first start off by recognizing John Tukey. He developed the foundations for EDA or exploratory data analysis. So this is the first critical step to understanding complexities of observation. Okay, so let's discuss data frames. They are data structures that organize data into a two-dimensional table of rows and columns. Think Excel, hence the reason why I've got this open. So we've got our rows, and then we've got our columns, which can also be called variables, attributes, fields. There also can be called inputs or predictors, and the rows are also called records. So I'm just showing a visual example of a data frame. Now let's discuss structured data. There are two main types, numeric and categorical. When we think about continuous data, we're talking about data that can be measured. Think wind speed or time. Discrete data is data that can be counted. Think how many siblings you have. 1, 2, 3. They can be categorical counted. Data only takes on a fixed set of values. Think state names, Alabama, Texas. Binary data falls under this, 0, 1, true, false, as well as ordinal data, which has an explicit ordering, beginner, intermediate, expert, etc. Rectangular data is a two-dimensional matrix. We have rows for records and columns indicating features. There are also non-rectangular data structures such as time series, spatial data, or graphs. This book focuses on rectangular data, so that's what we will be talking about. And we will discuss estimates of location such as mean, outliers, weighted mean, and variability metrics such as standard deviation and percentile. When we discuss mean, we are seeking an estimate or where most of the data is located. We've got our weighted mean, which is the sum of all values times a weight divided by the sum of the weights. We have a mean, the sum of all values divided by the number of values. And we have outliers, a data value that differs from most of the data. And here we are showing you a snippet of code, how to retrieve the mean or how to get the mean. You enter the dataset, that specific column, and then the mean function. Using weighted mean ensures that more significant data points have a greater impact on the average, which can lead to a more accurate representation so you're not skewing the data. The book is giving us an example of a built-in function to retrieve or to calculate the weighted mean in a data frame. Like I was saying, outliers could skew the results. However, some outliers represent natural variations in the population, and they should be left as is in your data set. These are called true outliers. And so now we are going to look at variability metrics. So there are different ways to measure variability. We're looking about how far apart points lie from each other and the center of a distribution of a data set. So we're looking at the spread or the dispersion. And so we will be taking a look at the standard deviation, which is the square root of the variance, as well as percentiles. And so the Pandas data frame provides methods in order to calculate this. And we could also find the interquartile range. Okay, so now let's dive into some code. We will be using Jupyter Notebook. Okay, so we've got our Jupyter Notebook open, and now we are just going to import some libraries into our kernel here. So I am importing Pandas, and I give it an alias, Pandas as PD. This is the standard naming convention. I'm also importing NumPy as NP. Then we're going to import some of our visualization libraries, Seaborn, and we're saying as SNS, and also matplotlib.pylab. Matplotlib is a library that is made for visualizations as well as Seaborn, and NumPy is for our mathematical calculations. And Pandas is used for data analysis and data manipulation. We are adding a style here to our matplotlib. We're adding ggplot, and then we are adding this option here, and we will see why this option is added. It really is just so that we have a full view of all of the columns in our data frame. When you're running or when you're pulling in a large data set, a lot of times Pandas will not show every single column if it exceeds a certain number. And so this is just saying, hey, if I have 100 or less columns, show all of these column names in the window. And so now I'm also adding my directory here. And so my files are kept in the C drive, in the desktop folder, in the TIA folder. So I see there's an error, and it's because of a typo. I did not put in the O on matplotlib. So now we run that and we are okay. So just showing you that we first had to import our libraries here in the Jupyter Notebook. And we did go over a high-level overview summary of Chapter 1. Of course, I did not go into a lot of detail, so I would definitely recommend buying the book because it covers more than just what we've covered in our high-level overview. And so we're going to be doing 2 parts here. In part 1, analyzing and investigating data, as well as the data prep or the data processing. And so I'm just showing you here that there are tons of data sets that you can practice on. This is good for if you are working on a portfolio or if you are looking for a data set to analyze. You can incorporate this in your job portfolio. So there's all types of data sets: health, energy consumption, buildings, world population, pollution, basically anything you can think of. There's a wide array of data sets. So I would definitely recommend going on Kaggle. Kaggle also has tutorials. And so if you're looking to either freshen up, get a refresher on certain languages, SQL, Python, this also discusses some machine learning, I would give Kaggle a go and just explore. And so the data set that I am using is a Titanic data set. I pulled this data set from the Pandas documentation. And what I'm doing here is I am first naming this variable. So the variable is df, and this variable will hold our Titanic file. So we are declaring a variable, and it's df, and we're pointing df to read in a CSV file called titanic.csv. And just a reminder, you can pull in multiple types of formats, not just a CSV. So I was showing you, you could also pull in an Excel file. So I'm just showing you, this data set is saved on my local drive under desktop and TIA. And I'm just pulling this open so that you can see this is the Titanic data set. So this is on my local computer. And so what I want to do is pull this data, ingest this data into Pandas, into Python. And so this code here, the df equals pd.read underscore CSV Titanic, this is pulling this data set into our, we can see it inside of our kernel here. And so I'm just showing you, it's the same thing, right? So we've pulled in, we have 891 rows and 20, let's see how many columns. I think it's 12 columns. Yes, 12 columns. So this is we've got only 12 columns here, so we can see all of our columns. But if we had something like 200 columns and you want to just scroll with the scroll bar, you'll be able to see that if you adjust that code up top to say, hey, you want to see at least 300 columns. So that's what I was showing. And now we are pulling up. So we are showcasing the shape attribute. This is for the data frame method, and it shows us how many rows and columns we have. So it's giving us the dimensions of our data frame. We also have df.columns if you would like to see a bullseye view of all of your columns in that data set without pulling the actual values under the columns. And now we are looking at the df.info. So when we type in df.info, it's giving us the info for this data frame. It's telling us what our data types are, if they are nulls, if they're objects, if they're floats, if they're ints. And so it's good to just see an overview of what type of data is in your data frame. And now we are going to pull up df.describe. This gives you a statistical summary of your data. So let's run that. And so now here we are able to see the statistics for each of these columns here that contain numerical values. So we've got the count, the mean, the standard deviation, min, and certain percent quartiles, as well as the max value. So you see we've got our, so basically under every column, it is giving us some summary statistics. So this is very good to see just a high-level description of what it is that we're working with in our data set. And so I'm just showing you what if you do not want to see for all of the data frame, all of the numerical columns. If you just want to sort of subset and just look at specific columns and see that summary, you can. So I'm just pulling in 2 columns. Okay, I've got an error here. Can anyone guess what the issue is? So it's saying key error. Okay, so the namings are correct. So we do have age and fair. So let's check. I think it is because it is pulling multiple columns. So you need that double bracket, and that is correct. So now we see age and fair, and it's just giving a subset of our data frame. It's just showing us the age and the fair. Okay, so right now it looks like I am grabbing some of those column names, and you see I just went up to the script where we were looking at the column names. I just copied that, and I'm making a subset. I want to only pull maybe 5 column names, so I want to subset my full data set, and so I'm naming this subset. And so this subset just contains the 5 columns that I listed. See, we see that the row count is the same, but the columns have reduced from 12 to 5. And now we're going to check, are there any NA values within this data set? So NA is where the value is actually NA. Or you can have null values where there are no values. There's actually missing data. So we're actually checking here now to see, well, how many NA values do we have? And in what columns does that exist? So we are just typing in the script, and now we are wanting to drop those NA values. So I'm preserving the original data set, and I'm naming the data frame that has the dropped NA values in DF1. So we are dropping that, and now we are checking the sum to see if they truly were dropped, and we see there are zero observations of NA values within our data frame. And so now what I'm doing here is I am changing the order of the data frame. So I typed out a list of the columns, and now I'm saying, hey, I want the embarked field to show up first. And then I am putting in the rest of the specified order in which I would like to see. So I would then like it to be followed by the survived, then P class name, and so forth. So we are rearranging the order of the data frame. And now we have saved that in the variable df1. And when we run that, we see that embarked field is showing up first. And now we are showing what if we would like to rename one or more of our column names. So we would type in we would say rename, and then we would say columns equals followed by curly brackets. And then we're typing in the original name of the column and then the name in which we would desire the column to be. So we are converting from P class name to passenger class. And so this is how we're doing that. If you would like to do multiple columns, then you would just place a comma and follow that same format. So we just renamed, and we could see the outcome here. We have successfully renamed that column. Now we are looking to see if we would like to drop a column. We can drop one or many columns. So what we're doing, we're just typing in df1.drop, and we would like to drop the ticket column as well as the cabin column. So we are passing in the drop function, and we are just setting that name to df1. Okay, and we've got an error. It's saying it's not found in the access. So can you guys spot what is wrong? And this is a like real life process of data science, software engineering. There will be debugging. You will have to figure out, okay, why are you getting errors, especially when you are new. So we're just checking, okay, is ticket and cabin, are those fields within our data set? Yes, they are. So why is it giving an error? Oh, okay. Is it because I need to put additional brackets because we're looking at multiple columns? And no, that is not the issue. So what could it be? So we see here that we forgot to specify the axis. So in Pandas, 1 refers to the vertical axis or the columns, and axis 0 refers to the horizontal axis or the rows. So you have to specify that. And now we see that we have successfully dropped the ticket and cabin columns from our data set. You see, they're not there. And now we would like to analyze and see, do we have any duplicates within our data set? And as we can see, this is giving us Boolean true false statements if duplicates exist. And now we'd like to see, okay, well, show me, right? So this is just showing if it's true or false, but I want to actually see exactly what those duplicates are. So we are passing in the lock function, and we are checking to see if it will show us what is duplicate. So we see here that we actually do not have any duplicates in this data frame. And now we would like to investigate the mean or the average of a specific column. And I showed this in the prior overview of the chapter. So we're literally just putting in the data set name or that variable in which the data set lives, passing in that column, and then typing in the mean function. And now we are going to group by 2 columns in our data set, age and sex, and we are going to find the mean here. So we are running that. Another error. Let's see. It's because it is not capitalized. So key point, everything has to match exactly. So this was lowercase, we had to uppercase this. And so now we see that the sex and the age were grouped and we see the mean of each. Okay, so this is it for today. This was just a part 1. We will have a part 2 followed by a day in the life of a data scientist. Thank you for watching. Don't forget to subscribe, comment, and share. Subscribe for a day in the life of a remote data scientist.